Hello, everyone. Welcome to my class in Accountancy, Business, and Management 2. Today, we will be continuing our discussion and interest, but this time, we will talk about compounding interest. Okay, this compounding interest is a mathematics in explosion. Why? Because there is exponential growth in compound interest. Why? Because compound interest is known as the eighth wonder of the world, as Albert Einstein calls it, because if you know compound interest and use it to your advantage, you will earn much. But if you do not know compound interest, well, you have to pay for it. Well, so that I could explain it how, let me give you an option, okay? Suppose I'll give you option A, wherein I will give you 50,000 for a start for day one until the 20th day. I will add 10,000 more daily. Okay, from the 50,000 seed money, I will add 10,000 every day. So first day is 50,000, second day is 60, third day is 70, so on and so forth. But option B, I'll only give you 100 pesos, okay? The seed money is only 100 pesos, but it doubles daily. Okay, it doubles daily. Okay, so now tell me, where do you want, what option would you choose? Option A, the seed money plus 10,000 more, the seed money of 50,000 plus 10,000 more, or option B, 100 pesos as the seed money, but it doubles, okay, over time for 20 days. Okay, now give me your answers. Who says option A? Who says option B? Okay, now I have given you time to think and I will show you the facts. Let us do our own computation. It's better to see the figures because it's a visual representation of the promise that I made. Okay, so here on the first column, that's the number of days, first, second, third, up to the 10th day. On the first column, it's the first option, 50,000, the seed money, plus 10,000 more every day. So if you will observe, 50 goes to 60, goes to 70, 80, 90, 100 on the sixth day, and so on and so forth. Then the 100 fund, seed fund that I gave you, seed money, grows 200 on the second day, 400 on the third day, 800. Why? Because it doubles every day. Okay? The balance is doubled by the day. So that's 1 to 10th day. Haven't you noticed? Option A is still the highest in terms of figures. On the 10th day, option A, you will receive 140,000. But in option B, your balance is only 51,200. Now let us look at the 11th to the 20th day. Okay, from the 11th day, still option 1, option A is gaining much than option B. However, look closely, look closely on the day 12. Day 12 here, look, do you see day 12? How much will you earn on day 12 using option A? Well, you have 160,000. But in option B, how much is your money? Your pot has become 204,800. That is more than option A. Okay? Now, on option A, on the 13th day, it becomes 170. While on the option B, it becomes 409,600. It has jumped up. Okay? It has grown exponentially. More so on the following days. 14th day, it grew to 819,000. And on day 15, how much is the money? On option B. So it grew to 800. Oh no, on day 15, it became 1,638,000. But look at option A. It has remained to what? 190,000. Way, way far. because in option B, we already have 1,638,000. So on and so forth. When we go to 16, it has become 3 million. On 17th day, it has become what? 17th day, it has become 6 million. 18th day, 13 million. And 19th day, it has become 26 million. And on the 20th day, it rose up to 52 million. Way, way ahead than the 20th day in option A, which is 240,000. Well, now, my students, can you tell me the analysis between the two tables, the option A and the option B? Yes, very good indeed. You have just mentioned that money grows over time. Money grows over time. Okay? It slowly, okay, you will notice that on the first few days, on the first day until the, here, on the first day until the 10th day, it option B is still very low, 15,200, while in option B it has grown already to 140,000. Why is that so? It shows to us that option B slowly and slowly and slowly grows until it reaches its peak. But when it has reached its peak, in Tagalog, we call it bumubulusok yung kanyang pagtaas. Okay? Or explosive. In English, we call it explosive or exponential growth. Do you understand now? So option A is the simple interest, wherein the interest is flat at 10,000 even distribution of interest. So it is flat rate. However, in the option B, wherein we will be using compound interest, it rises up so explosively, so exponentially, way behind simple interest. But it grows not on a few number of years, but over a long period of time. That is 1 to 20th day. Or if you convert it in years, 1 to 20th year. Okay? So, what matters in compound interest is the time, okay, the time factor, and the what? Of course, the rate, and of course, the principal amount. But what makes it exponential? Because of the number of times the interest is compounded, or the number of years you have invested such amount. Okay? So the time factor and the n factor. So for further explanation, I will show you the formula for compound interest. Okay. So here it is. Next we have, okay. So here, compound interest says it pays interest on both the principal and the interest an account has already earned. For example, you put what's this? You charge the interest not only on the principal but on the accumulated interest. Okay, so in short, we call it interest, interest on interest. So very simple. You're earning interest from your previous interest or accumulated interest in the previous time. Okay, so the formula as it is being shown in the slide, A is the amount, the final amount or the maturity value or the future value. Okay, so A is the final amount, P is the initial amount invested. Okay, that's the first time, the first amount that you invested in the company, and the R stands for the rate. But when we see an interest rate written in percentage, we have to change it into decimal. Percent means divide it by 100. Okay? So if you have seen 14%, divide 14% by 100, so it will give you 0.14. Okay. So, next we have the N, the number of times compounded in a year. What do you mean by number of times compounded in a year? So, meaning the interest could be divided several, was this could be divided several times in a year. It may be first is annually, you receive interest once a year, okay? Or semi-annually, you divide the interest by 6 or by 6, so you earn interest 2 times a year. Quarterly, you divide the interest by 3, so you earn interest 4 times a year, quarterly. So monthly, you divide the interest by 12 divided by 12, 12 divided by 1 is 12. So you earn interest monthly, every month, okay? So that makes it exponential. That makes it very explosive. That makes it a very high return on investment. Okay. Next we have, okay, here. So again, the formula A is equals to P. What is again P? Yes, correct. P is the what's this? The initial amount invested. A is the what? Correct. It is the amount or the maturity value of the investment or the future value. Okay, multiply it by 1 plus the R. R is the what? Right, the rate of interest. We have to put it in decimal form. Okay, translate the percentage in decimal. Excuse me, in decimal form. Divide it by the n. N means how many times is it compounded in a year. Okay, I have shown it there. Then you will raise it to the exponent n times the t. T is the number of years the money will be invested. Okay, so if the n or the interest is compounded annually, for example, at 50,000 principal amount, 50,000, multiply it by 1 plus the rate of interest, which is 0.14. Okay, that's annually. But if it says semi-annually, you multiply 50,000 by 1 plus 0.14, divide it by 2. Why do you divide 0.14 by 2? Because 0.14 by 2 is what? 0.07. That means you earn interest twice a year. You divided the 14% by 2. So for semi-annual, you earn 7% or 0.07. And the second 6 months, you earn 0.07. Okay. The same with quarterly. You divide 0.14. Okay, 0.14. Divide it by 4. So how much do you get? 0.035, the rate of interest. 50,000, if you do it monthly, 0.14 again, divide it by I think that's 12. Oh, yeah, that's 12 because it's monthly. Okay. So the rate of interest is 0.012. Next we have, okay, so let's do this. Okay, let's try solving this. The problem says the principal amount is 50,000 compounded once, okay, annually at a rate of 14%. How much is the maturity value or how much is the future value? So the amount is equal to P is times 1 plus R equals to 50,000 plus 1.14. So 1.14 times 50,000. So how much is the future value of your 50,000 now? That after a year, it becomes 57,000. Okay, that's for the annual compound. How about for the semi-annual compound? Okay, here, compounded semi-annually, the same problem, 50,000, but for the n, we put 2. Okay, because it is semi-annual. So the rate of interest divided by the n, which is the how many times is it compounded in a year. So you divide it by 2, you get 0.07. So 1.07 raised to 2 or raised to the second power. Why raised to the second power? Because the n is compounded semi-annually. Okay, that's why we raised it to 2. But the time is still the same, 1 year, so you need not write 2 times 1. 50,000 times 1.07 times 1.07 raised to the second power is 1.1449. 1449 times 50,000 will give us 57,245. So that is the future value. Now let's go to the next slide. Okay, when the problem says it is compounded quarterly, the n becomes what number? Yes, correct. It becomes 4. Because you divide 12 divided by 3 is equal to 4. So there are 4 quarters in a year. So 0.14 divided by 4 will give you how much? 0.035. So 1 plus 0.035 is 1.035 raised to the fourth power. Why did we raise again to the why did we raise this number, this figure to the fourth power? 4 here resembles the what? Quarterly. Okay, quarterly. The n. The n. Okay, here the 4 here resembles the quarterly. Okay, also the exponent 4 resembles the quarterly. Okay, compounded quarterly. So you put n as the exponent. Okay, so 50,000, 1.035 raised to the fourth power, or you multiply 1.035 four times. 1.035 times 1.035 times 1.035 times 1.035 will give us what? 1.1475. So 50,000 times 1.1475 will give us how much? 57,376.15. Okay, so that is when it is compounded quarterly. Now let's go to the next. If it is compounded monthly, okay, when it is compounded monthly, your n becomes what? It becomes your n here, your n here, the monthly, you replace it with 12 because it is monthly, compounded monthly. So 0.14 divided by 12 will give you how much? 0.012. Here, 0.012. Okay? But it is again raised to the 12th power. Why? Because of the compounded monthly figure is 12. Okay? So raised to the 12th power. So 1.012, you multiply it 12 times, it will give you how much? 1.153 times 9. Multiplied by 50,000, it will give us 57,694. Next, we go to the next slide. Okay, so here it is. So now let's compare everything. Which one would you prefer? Compounded annually, semi-annually? Okay, compounded annually, which is how much? 57,000. Compounded semi-annually, your proceeds or your maturity value is 57,245. Quarterly is 57,367. Monthly is 57,694. So which do you think is the best? To compound it monthly, quarterly, semi-annually, or annually? Okay. So when we say we compound the interest, we divide it by the what's this? By the required, if it is annually, you divide it by 12 divided by 12 is 1. 12 divide it is compounded semi-annually, 12 divided by 6 is 2. So that's it. So in this case, what do you think is the best way? The to compound it annually, semi-annual, quarterly, monthly. Yes, it is correct. It gives you a highest return in the monthly compound or monthly compounded interest rate, 57,694. Okay, now let's go to the next slide. Okay, compound interest. Okay, June 17, 2021, Ben invested 20,000. So let's try solving. He invested 20,000 in a at a rate of 10% compounded annually. So Ben will not withdraw the interest. So how much interest and maturity value will he earn in 1, 2, 3, 4, 5 years? So meaning how much is the future value of the investment? Okay, he invested 20,000 in year 1. If you will notice here, 1 times 10. Why 1 times 10? 1 plus the 0.10% rate of interest, and once only because year 1. Okay, year 2, multiply it by 1.10 times 1.10. So you have a maturity value of 22,000. But I have shown here also the column for the maturity value or the face value. No, maturity value or the future value. Okay, 1.1 is 1.10. Okay, 1.10 times 1.10 is 1.210 and when you multiply it by itself three times, this is the answer. Then when you multiply it four times by itself, 1.4841, and you multiply it 1.9 by five times, 1.6105. Okay, my dear students, you can also use the tables. Okay, there is a future value table and the present value table. But for now, I have asked you to bring your future value tables so that you can infer from that. Look at the on the left side is the term, okay, the term of 1, 2, 3, 4, 5 up to I think it's up to 60, 20, 40 years or more, and on the top row is the what? The interest column. So you just locate the interest and the time, and there you get the factor, the present value, no, the future value factor. That this is it, 1.1, 1.201. You can find it also in the future value table or in the calculator. I will teach you in the Google class how to do it or maybe in another YouTube presentation. Okay. So today you will be looking here the maturity value. What is the maturity value in year one? So it has become 20,000, 22,000. How much is the interest? 2,000. Okay. Then here also, the maturity value is 24,200. The interest is 1,200. Okay. No, the interest is 4,200. Year 3, it becomes 26,200. 26,200. Fourth year, it becomes 29,282. And on the third year, it becomes 32,210 with an interest earning of how much? 12,210. So the question of present value, the present value is the amount today. So the amount you invested is how much? The present value is the amount you invested today. So the present value is 20,000. Very good. But the future value is the amount of the principal plus the accumulated interest over the years. So it has become 12,210. So 30,000 plus 2,210. So you get a future value of 32,210. Do you see it? Here. Okay, that's the maturity value or the future value compounded annually at 10% in 5 years. So the interest is how much? 12,210. Isn't it very easy? Yeah. Next. Okay, here are two ways to compute for your compound interest. Anyway, any way of the two will yield same answer. But I still have to show it because maybe some of you will be using different methods. Okay, here 20,000. Look at the column for the principal. The principal here. Sorry. Undo. What did I? Sorry. Okay. Uh-huh. I think I moved some figure. Okay, so here, where is the undo here? On anyway, I cannot undo it anymore. But the year is your 20,000. Okay, maybe I have to move this back. Okay, sorry. Here, compound. Future value should be here. Oh my goodness. Future value should go up. Anyway, so your 20,000 balance. No, but it has moved. It should be here. Wait. We have to move this. Yes. How much? Okay. Okay, the figure has become so small. I can't even, I can't, ayun, that's it. So this has become 24,000. But we have to move here. So it can be, ayun. So it has, okay, it has returned. So the 20,000 amount on year one, it has gained interest of 2,000. So for the first year of 20,000, it earned 2,000. How much is the interest? 2,200. So your balance is now 24,200. From the 24,200, you multiply again the interest of 10.10 times 1. So you earn another interest on second year of 2,420. So how much is your new principal? 26,220. Look at this. 26,220. It becomes your new principal where you base your interest. So your interest is earning interest from the new balance of your principal. Okay? So notice here that the principal is growing every year. It is not static. Okay? So then at the end of the 5 years, the future value is 32,210. Look at this figure in yellow. It is now 32,210. And how much was the interest? You earned 12,210 interest in 5 years. You can also compute it this way. Okay? 20,000 times 1.1. Okay, 1,000, 1.10 is the future value factor. So you earn 22,000. The compound interest is 2,000. The second year is 2,200. The third year is 2,420 until you get the 12,210 interest on the fifth year. So it's very easy. Now, the present value of 50,000, okay, here you use the exponent 1.1 raised to the second power. Here you to the third power, to the fourth power, and to the fifth power. Okay, my dear students. So the present value of 20,000, okay, that's the original amount. Then the future value is the principal of 20,000 plus this one, the interest earned of 12,210. So your future value of the 20,000 you invested today is how much? 32,210. Very good. Next we have, okay, okay, next we go to, okay, but we can also compute it the shortest way, okay? To know the future value is 20,000, okay, the principal, multiply it by 1 plus point 0.10. Okay, why point 0.10? Because of the 10% rate. Raised to how much? Raised to the, how much power is this? I think this is 10, 10% rate, and 1t is 5. So raised to the fifth power for 5 years. So 1 plus point 0.10 raised to the fifth power. If you go to your future value table, use a future value table here. 1.605, where did you get this? When you use your future value table, okay, you will immediately get the future value factor of 1.6105. Okay, so the present value of 20,000 today, when compounded annually at 10% rate for 5 years, it will become how much in the future? It is now valued at 32,210. Okay, very good. Next, that's the easiest way to solve it. Next, we have also, now we're done. Okay? So, we're done with the compound interest. Okay? And for the next day or next meeting, we'll be comparing the simple and the compound interest. Okay, thank you very much. Have you learned something? How to use, did you see the magic of how to use the compound interest? I hope so, and I hope you can apply it soon. Once you graduate in grade 12, you can already be employed as bookkeepers, as I have been telling you. I have been equipping you with the skills, the tools on how to become a bookkeeper. And then once employed, how much should you set aside for your investment? For the first 5 years, I think you can keep money. Okay, you can save money and then put it in an investment. And after 5 years, you can build your own enterprise or business, okay, without getting into debts. Because we know that when we encounter debts, debts are the interest is compounded, so it will not work to our advantage. Okay, so but we will see. We will try with the tools that we are equipped. We will see if the money that you will be borrowing is simple and compound, and we will see if the interest that you will be paying is worth it, worth the project that you will be doing. Okay, thank you so much, and God bless everyone.